On this video, you will learn the two basic probability rules. First of which is the multiplication rule. To determine the probability of occurrence of two independent events, we use the multiplication rule. When we say independent events, two events are said to be independent if the occurrence of one has no effect on the chance of occurrence of the other. So it states that the probability of occurrence of two independents, for example, events A and B, is equal to the product of the probabilities of the individual events. Symbolically, we can denote the multiplication rule by the probability of events A and B is equal to the probability of event A times the probability of event B. For example, in tossing two coins, what is the probability that a head will occur both on the first coin and on the second coin? So in order for us to solve for its probability, we will use the multiplication rule. But first of which, let us find the probability of each event. So we have learned last time that the probability of an event, so the probability of an event is equal to n all over n, where n on our numerator is the favorable outcomes and n on the denominator is the possible outcomes. So on a toss of coin, what is the probability that we are going to acquire a head? So what is the number of favorable outcomes? We only have one head. And the total number of possible outcomes is 2. Therefore, the probability of obtaining a head is 1/2. So computing now the probability of obtaining a head on the first coin and another head on the second coin is equal to the probability of, so that will be the probability of head on the first times the probability of head on the second coin. So we all know that the probability of obtaining a head on one coin is equal to 1/2. Then, the probability of obtaining another head on one coin is also 1/2. So multiplying now, so 1/2 multiplied by 1/2 is equal to 1/4. Therefore, the probability of obtaining a head or both head on tossing two coins will be 1/4. Another example, suppose that the probability of a typical driver will have an accident during a given year is 1/10. What is the probability that two randomly selected drivers will both have an accident this year? So this is more easier to calculate because the probability of each event is already given, which is 1/10. So computing now the probability of two randomly selected drivers, that will be the probability is equal to 1/10 times another driver which has a probability of 1/10. So multiplying now, that will be 1/100. So the probability that two randomly selected drivers will both have an accident this year is 1/100. That is the multiplication rule. So the next will be the addition rule. To determine the probability that one or another event but not necessarily both, will occur, we use the addition rule. The addition rule states that the probability that event A or event B or both will occur is equal to the sum of the probabilities of each individual event minus the probability of both. Symbolically, the addition rule is denoted by the probability of event A or B is equal to the probability of event A plus the probability of event B minus the probability of events A and B. For example, in flipping two coins, what is the probability of having a head on the first, or on the second, or on both? To get the answer, we use the addition rule. So, that will be the probability of events A or B. So, on our example, that will be the probability of obtaining a head on the first or head on the second is equal to the probability of event A, which is the probability of obtaining a head on the first, plus the probability of event B, which is the probability of obtaining a head on the second, minus the probability of events A and B, which is the product of events A and B. So that will be, so the probability of the first event times the probability of the second event. So we all know that the probability of obtaining a head on a toss of coin is equal to 1/2. So that will be 1/2, then another 1/2 minus, so the product of the probability of both events, which is 1/2 times 1/2. So simplifying it further, so 1/2 plus 1/2, that will be equal to 1, minus 1/2 times 1 will be equal to 1/4. So 1 minus 1/4 is equal to 3 all over 4, or 3/4. Therefore, the probability of having a head on the first or head on the second or both head in flipping two coins will be 3/4. Another example, what is the probability of obtaining 3 or 4 on one toss of die? So we'll be using the addition rule. On this example, so the probability of events A or B, that will be the probability of obtaining 3 or 4 is equal to the probability of event A, which is the probability of obtaining 3, plus the probability of event B, I should say, which is the probability of obtaining 4, minus the probability of both events. So that will be the probability of obtaining 3 times the probability of obtaining 4. So what is the probability of obtaining 3? So the probability of obtaining 3 on a toss of die, so the number of favorable outcomes, there is only 1 3 on a die, so that is 1. Then the total number of possible outcomes, so there are 6 faces on a die, so that will be 1 all over 6. Same with 4. So the probability of obtaining 4 will be 1 all over 6 as well. So that will be equal to the probability of obtaining 3 is 1 all over 6, plus the probability of obtaining 4 is also 1 all over 6, minus the probability of obtaining 3 and 4. So on a toss of die, we cannot obtain the probability of event 3 and 4 because they are mutually exclusive events. When we say mutually exclusive events, these are events that cannot happen simultaneously. That is, if one event happens, the other event cannot happen. Therefore, the probability of 3 and 4 will be 0 because it is impossible for us to obtain 3 and 4 in a single toss of die. So that will be 0. Then, simplifying it further, so 1 all over 6 plus 1 all over 6 is equal to 2 all over 6, or that will be 1/3. Therefore, the probability of obtaining 3 or 4 on a one toss of die is 1/3. So those are the two probability rules, which are the multiplication rule and the addition rule.